Good evening, everyone. Myself, Dr. Subhranshu Padhi from Department of Electrical and Electronics Engineering, Sambalpur University Institute of Information Technology. In this particular video, we are going to understand what is a Triac, what is a Diac, and how the Triac is triggered using with the help of a Diac. Now, first of all, in the last three videos, we have seen what is SCR, and there are three different methods of triggering a SCR, like R firing circuit, RC firing circuit, and obviously Diac based firing circuit. Now, coming to Triac, what do you mean by Triac? Triac is nothing but triode for alternating current. Triac is a minority carrier bidirectional semi-control device, where the SCR is a unidirectional semi-control device, and but the Diac is a or the Triac is a bidirectional semi-control device. So Triac has three terminals: one that is main terminal one MT1, main terminal two MT2, and the gate. So obviously the Triac is turned on by injecting a current pulse to the gate terminal. Once, so this is the Triac is, you can see the Triac as the two SCR are connected in anti-parallel mode. Two SCRs are connected in anti-parallel mode. This is a Triac MT2, MT1, and this is the gate terminal. And this is the VI characteristics of SCR. So whatever it is the same in the forward direction, it is same as SCR, but in reverse direction also it is same in the in the forward direction. That means this is a bidirectional device. And see the major limitations of SCR and what is the advantage of Triac over here. In SCR, whatever the input waveform, only the positive half cycle was conducting and the negative half cycle was never conducting. But in Triac, both the positive as well as the negative half cycle is conducting. You can see the firing angle alpha, and maybe this is pi plus alpha. So the Triac, you have a input waveform, and this is the conduction waveform. And to trigger a Triac, we need a Diac. What is a Diac? In the last video also we have seen Diac is nothing but diode for alternating current. It has two terminals. This is a Diac PNP device. This is a three-layer bidirectional device which can be switched from its off state to on state for either polarity of the applied voltage. Now, this is the very basic VI characteristic of Diac. You have a minus VBO, that the reverse breakdown voltage, the forward breakdown voltage plus VBO, and IF and minus IBO. Now let's see a particular circuit. This is a Triac based voltage dimmer. More or less, this is same as the previous circuits we have discussed. There is a source, there is a load, AC source, there is a load, bulb load, obviously AC bulb load. There is a, instead of SCR, we have a Triac, and for triggering of the Triac, we need a Diac. And here, obviously, the RC circuit is there. So let's do this in Multisim. I'm using Multisim 11 over here. Let's check out. First, let's take the AC power. We have taken the AC power. Then let's take a ground, D ground or ground, whatever you can take. Then let's go to the select all groups. And here we have a lamp, 120 volt 100 watt lamp I am using for the load purpose. Now the source is there, the load is there. Now I am going for SCR. So the SCR or the Triac, sorry, we are going for the Triac. Triac, any one of the Triac you can use, 6071, 2 and 6071. A very useful Triac is BT136, that also you can use, BT136, but we are, for this particular case, we are using 2N6071. And again we are using that Diac. A Diac is basically 1N5761. Diac we are using. So the Triac and Diac are connected. Now we are going to connect the resistance basic, and here you can use any resistance. You can use a metal film resistance, you can use a carbon film resistance, it depends on you. And let's a non-polarized capacitor. Let's use a non-polarized capacitor over here, and again a potentiometer, 10 ohm potentiometer. So let's rearrange these things. Control R, if you select it all and Control R, you can easily change the orientation of this, and let's do some things. Now it's okay. Now let's connect all these circuits, and here we are connecting to the ground, here we have connected to the sim diode, load, and triac, and here we have connected BT. So the negative terminal we are connecting it to ground over here, and we are connecting it over here a ground. Now let's change the values. This is obviously 50 hertz, and here I am connecting it to over here, and this will be my 47 kilo ohm and 330 kilo ohm. So let's change the value to 47 kilo ohm and here to 330 kilo ohm, and the value of capacitor is 0.068 microfarad, 0.068 microfarad, and I am connecting over here the Diac and the Triac. Now let's see the wave for the waveform purposes. I am using the Tektronix DSO. First, let's check the input waveform, checking the load voltage, checking the thyristor voltage, as well as checking the Diac voltage. This is a 4-terminal Tektronix oscilloscope. Now let's see over here. You can see the bulb is blinking. That means you are getting the voltage dimmer circuit is working fine. This Triac as well as the Diac. The Diac is triggering the Triac, and because of the triggering of the Triac, the bulb load is having a blinking. Now let's switch on the CRO. So channel 1 is used for the input voltage. Yeah, as you can see, 4 channels. The input voltage, let's just cut it out for some extent, so that okay, it's not coming as it is. We can always change, because this is 120 volt, so that it is out of the scope. So we can obviously change the position, and here you can see the input, complete input voltage. And here the channel 2 is basically the second channel. Over here the output voltage, as well as the channel 3. Channel 3 is thyristor voltage, as you can see, the positive as well as the negative. And this is the Diac. Diac is acting as a zero crossing detector. This is acting as a zero crossing detector to the source voltage, basically. So this particular circuit is working properly. You have a input voltage, you have a load voltage, you have the thyristor voltage, as well as you have a Diac voltage, which is acting as a zero crossing detector, right? So this is the circuit, a simple circuit, a SCR, sorry, Triac and a Diac. So this completes the simulation regarding the triggering of Triac using a Diac. Thank you.